All right, so we're talking about the Z distribution today, so exercise 8E. And what the Z distribution is it's a normal distribution. Okay, remember I've spoken about this mathematical notation before, right? Z is normally distributed with a mean of 0 and a standard deviation of 1. And this is what we call the standard normal distribution. So here I've sketched it, and you can see the further away you get from the mean, the larger those Z values get, right? So we have positive Z values are above the mean, negative Z values are below the mean. Now what we're going to do today is calculate a Z score, and that is a measure of how far a result is away from the mean. So it's a way of comparing different distributions, and that's the formula for calculating a Z score. So let's get straight into the example. We've got Rob receives 83% on his maths test, which has a mean result of 74% and a standard deviation of 6%. He also received 62% on his English test, which had a mean result of 55% and a standard deviation of 3%. Which test did he do better on? So we're comparing these two different distributions. So his Z score for maths, all right, I'm going to call that Z subscript M. It's going to equal the result that he obtained. He got 83%, right? So X here is the result that we want to know the Z score for. So he got 83. The mean for the class was 74. And the standard deviation is 6%. And so all we're doing is evaluating that. 83 takes 74 will be 9, divided by 6, 1.5. He has a Z score of 1.5. What that means is the result that he obtained in the maths test is 1.5 standard deviations above the mean. This is where he performed for maths, okay? Relative to the rest of the distribution, relative to the rest of the class. All right, so then we'll do it for his English test. So the result that he obtained, 55%, you might look at that go, sorry, 62%, not real flash, is it? But the mean was 55 and the standard deviation was 3. So they're all quite close together, these results. So his result, take the mean divided by the standard deviation. So we've got 7 on 3, 2.3 recurring. So 2.3, that's going to be about here, right? That's his English. So the question is, which one did he do better on? Which one's got a higher Z score? Well, he did better on his English test, okay? Because it's further away from the mean. It's higher up the distribution. Very good. Okay, on to question 2. Given X is normally distributed with a mean and standard deviation, we're not told what they are, and Z is normally distributed with a standard deviation of 1 and a mean of 0, find A and B. So what we have here, I'm going to write out what it's got written. The mean, take 2 lots of standard deviation, less than X, less than the mean plus half a standard deviation, is equal to A less than Z less than B. Okay, so if we're going to draw this normal distribution, I'm going to sketch it here. We don't know what the mean is, so I'm just going to put the mean. And then we've got the mean take 1 standard deviation, the mean take 2 standard deviations. Here, the mean plus 1 standard deviation. Now we're asked to find the probability from below 2 standard deviations below to half a standard deviation above. So I'm going to shade that region. All right, that's going to be this region here, right? So we have 2 standard deviations below the mean, half a standard deviation above the mean. And we're saying, what are the values of A and B that correspond with this distribution on the Z distribution? So remember, a Z distribution has a mean of 0 and a standard deviation of 1. So if we're going 2 standard deviations below the mean, here's going to be the minus 1, minus 2. This point here on the normal distribution corresponds with minus 2 on the Z distribution. So our value of A is minus 2. All right, and then how far are we going up? Okay, we've got half a standard deviation above the mean. What kind of Z score is that going to correspond with? It doesn't get to 1, it only gets halfway. A positive Z score of half So the value of B will be positive half. So you can see those straight from how much is the standard deviation varying here. All right, so most of this exercise is a fair bit like question 1, where you're comparing different distributions. And then there'll be a few that are a little bit like question 2. Pretty short, sharp, shiny exercise, so that'll allow us to dedicate some time to the folio. So let's get right into it.